Hello everyone. Today I am going to discuss the third problem of Leetcode Weekly Contest 439, which is sum of key subarrays with length at least m. So what we have to do, the problem statement is quite straightforward. We are given an integer array nums and two integers k and m. So we have to return the maximum sum of key non-overlapping subarrays of nums. Okay. So let's take the one example. Let's take one simple example. Let's take 1, 2, 3, 4, 1, 2, 3, 4, and let's say there are other variables as well. Let's say k equals to 1 and m equals to 2. Okay, m equals to 2, or let's say let's take another element 1 2 3 4 5, k equals to 1 and m equals to 2. Okay, that means we have to take only one subarray of length at least 2. Okay, so what we can do, we can take the entire subarray. Okay, we can take the entire array, then the sum will be 3 plus 3 6 10 15. Okay, now let's change the variables. It's our k is 2. If k is 2, then what is the optimal case? If k is 2, then we can take these two variable and sorry, if k is 2, we can take 1 2 3 and 4 5. Okay, so that is uh, how we can choose two non-overlapping subarrays. Okay, two non-overlapping subarrays of length at least 2. Okay, now how we can solve this problem? Now that is the question. Okay, how we can solve this problem? So before solving this problem, let's discuss the some samples. So 1 2 minus 1 3 3 4 and k is 2 m is 2. Okay, so what are the optimal choices? The optimal choices are from 0 to 1, so we can choose 1 2 and we just ignore this negative value. Okay, we just ignore this negative value. We can take the first two values and the last three values, the sum will be 13. Okay, that is how we get our optimal answer. Now let's discuss about constraints. Let's discuss about constraints and time complexity. Okay, now nums length is 2000 and uh, m is 3. Okay, so our values are, n could be 2000, n is 2000, m could be at max 3, m could be at max 3, and for k it is n by m, but let's take only 2000 only. Okay, so n is 2000, m is 3, and k is 2000. So overall time complexity that is possible could be order of nmk. Okay, so we'll try to solve this problem in order of nmk. Okay, now I'll solve this problem using recursion and memorization, and I'll define the recursion states. Okay, I am going to one recursion state to another, and how we are achieving this time complexity. So let's discuss the solution approach here. Okay, so whenever the constants are low, like 8 mk, then we can think that we'll take one variable which will denote n, one variable which will denote m, and another variable which will denote k. Okay, so and these three variables will be our uh, recursion parameters, and we will define our recursion states according to the parameters. Okay, so I means that the current index we are at. J means what? J means the number of characters we have already taken when we are at index I, and k means that number of subarrays we have already taken. So I hope you get it. I means the index currently we are at, j means the number of elements we are already taken in the currently running subarray, and k means the all subarrays which are already completed. Okay, so j elements are not included in the k subarrays. Okay, j means that we are in a new subarray, and whenever we will in this subarray, we'll decrement the value of k by 1. Okay, so I j k is our recursion parameters. Okay, let me write I j k is our recursion parameter. Okay, now so there are some cases. Okay, now let's say if j is 0, that means we have not taken any element. J is 0 means we have not taken any element. That means we can skip the current element. There are two possibilities here. If j equals to 0, then there are two possibilities. That is, we will take this current element. Okay, that means we are taking n of I, a of I nums. Let's consider nums as a. So we can say that this we have already taken this current element a of I. Now what will be our recursion state if we have already taken this element? Okay, now we'll go to our next index I plus 1. Now j will be 1 because we have already taken one element in the current subarray. So ai I plus 1 1, and k will not be decremented because we have not finished one subarray. So I plus 1 1 k, this will be our next state. Now another case will be, just we will just ignore this array. If we ignore this array, then our state will be I plus 1 and j will be same as 0 and k. Okay, so these are two recursion state. Now if j is equals to m, there are another state if j equals to m. Okay, j greater than equals to m, not equals to m, j greater than equals to m. That means that we can finish taking this Subarray. There are some possibilities here. I will explain what the possibilities. One is that we will just continue the Subarray we are at. We will just continue the Subarray we are at. In that case, what we can do AI plus uh, we can take go to the next index, and we will continue this Subarray. So this will be incremented by 1. So AI j plus 1 and k. This is one possibility. Another possibility is that we are finishing this Subarray. Okay, we are finishing this Subarray, taking this element. We are finishing this Subarray, taking this element. Then will be AI plus we'll be finishing this. So I plus 1 will be constant in all the recursion states, and we are finishing this Subarray. That means the next Subarray will be starting with 0 elements. So I plus 1 0, and we have already taken finished this Subarray, so this will be decremented by 1. And another case is that we'll just keep this element and we'll finish the previous Subarray. We'll just keep this element and finish the previous Subarray. In that case, AI will not be added, and the recursion state will be I plus 1, and we are starting another Subarray. So I plus 1 0 and k minus 1. Okay, so these are the three states if j greater than equals to m. Now here comes if j is between 1 to m minus 1. Okay, if j is between 1 to m minus 1, how will you handle this? If j is between 1 to m minus 1, there is only one case that we have to take this element. Okay, we can't really finish the previous Subarray with less than m elements. Okay, so there is only one case. We'll go to ai plus I plus 1 j plus 1 and k. Okay, I plus 1 j plus 1 and k. So there are three states if depending on the values of k. Now here comes one interesting part. Here you can see that we are incrementing the value of j plus 1, j plus 1. So you may think that the j could exceed n, j could be at most n also. Okay, because we are incrementing the value of j by 1. Now you can think that if j greater than equals to m, then it is same as j equals to m, right? If j greater than equals to m, then we don't have to increment j by m plus 1, m plus 2 like that. We can just keep j as m, and this the loop will come to this condition. So we can, instead of j plus 1, we can take minimum of j plus 1 comma m. We can take minimum of j plus 1 comma m whenever we are doing j plus 1. I hope you get this is the recursion. Now let's jump into the code. We'll just add memorization here. Overall time complexity will be here, n here, m here, and k here. Okay, so overall time complexity will be order of n m k. So this is the recursion. State is quite straightforward. Now there are some base cases. If k is equals to 0, that means all the Subarrays are taken. We'll just return 0. Now if I equals to n, this is a catch. This is an edge case. If I equals to n, that means there could be possibility that we have not finished the last Subarray. So now if the j equals to n, m means that we have already taken greater than equals to m elements in the last Subarray, and k equals to 1 means that we can finish the last Subarray. So if j equals to m and k equals to 1, that means we'll just finish the Subarray and return 0. Otherwise we have not finished our target to have k Subarrays, so we'll just return negative infinity. Okay, now here another important part is that in normal memorization problems we just take dpijk is minus not equals to -1, but here as the values could be negative, we have taken something which is not possible in normal dpijk. So if dpijk is int min, we'll just return dpijk. Instead of -1, we have initialized dpijk as int min. Okay, now answer is initialized with negative infinity. Now these are the recursion states I have already explained. I am not going further. The recursion states are explained here. Okay, all the recursion states are explained here. Now you can check that, and the rest of the part is quite straightforward. We are calling the recursion with 0 index, 0 taking elements taken, and k Subarrays remaining. Okay, I hope you get it. The problem is quite straightforward and quite interesting one also. Like this is a good problem to start DP, I think, to DDP, you can say. Okay, so if you find this video helpful, please like the video and subscribe to the channel, and also share among your peers. If you have any doubt in any part of the code explanation, you can always ask in the comment section. I will try to attach the code link in the description box. You can check that out also. Thank you for watching.